Hello, welcome to this lesson. In this lesson, we're going to continue talking about linear regression models. The focus of this lesson is going to be to talk about the strength of a linear model. That is what we call correlation. So let's go ahead and talk about our learning objectives. Your first learning objective is going to be to describe the strength of a linear relationship given a scatter plot or the correlation coefficient. Your second and last goal of this lesson is to find the correlation coefficient using technology. There's going to be a correlation coefficient, there's going to be a value, and when you look at that value, you're going to be able to describe how strong or weak a linear relationship is between two variables. So let's start by talking about how we describe the correlation of a linear relationship. Correlation, which always takes a value between -1 and 1 inclusively, meaning that the correlation can be equal to -1, it can be equal to 1, or anything in between those values. So correlation is going to describe the strength and the direction of the linear relationship between two variables. To be more specific, R is what we call the correlation coefficient. Now here's a note that I have. We could calculate the correlation coefficient R using the formula here below. We're not going to be using this formula. We're going to be using technology, but I wanted to show you how you would be able to calculate R without using technology. So if we're looking at this formula, notice we have 1 divided by n minus 1. Here, n is the sample size. If we have the data, we should be able to determine what the sample size is. So we know what n is. Okay? And then we're multiplying by the sum from I equal to 1 to n of this expression here. So here, what would we have to do? Well, we would have to take each of our data pairs and we would take our x value minus the mean of the x values divided by the standard deviation of the x values. We would multiply this by the y value minus the mean of the y values divided by the standard deviation of the y values. Again, if we had the data values, we would be able to find the mean and standard deviation of the x values and the y values. So we'll just have to repeat this computation for each of our data pairs, and then we would take the sum of all those values. Again, we're not going to be doing this by hand. We're going to be using technology. Our goal here is to be able to look at that R value, at the correlation coefficient, and be able to describe the strength of the linear relationship. Now, how are we going to describe the strength? Well, here are the three words that we use to describe the correlation. We can describe the correlation as weak, moderate, or strong. I mean, there's going to be times where we say the relationship is really weak, or somewhat weak, or somewhat strong, or very strong, or very, very strong, right? So we can add words to describe the degree or intensity of the correlation. But the most commonly used words that you're going to see when describing correlation will be these three words. Now let's look at an exercise where you're being asked to describe the correlation using the words weak, moderate, or strong. Here we have three different scatter plots, three different graphs. Each graph has a linear function, which is the regression line that best fits the scatter plot. Now let's look at the first graph, graph A. Notice we see that most of the points are clustered around the linear function. They're pretty close to our linear function. The correlation of this graph would be described as strong. Here you can make extra notes to yourself, so when you come back and look at your notes, you understand why we said that this is a strong correlation. Okay? Again, we're seeing that most of the points are being clustered around the linear function. Most of the points are close to the linear function. Now let's look at the next scatter plot. In graph B, we see a linear relationship. Notice, as the x values increase, the y values are increasing. Now, we see a bigger spread between each of the points in the linear function. So notice, if we talk about the residuals, the distance between each of the points to the linear function, we see that the residuals are going to be bigger than the residuals we would observe in the first graph here on the right. For graph B, we would describe this correlation as moderate. Again, we do see a linear relationship. We see that as x increases, the y values increase. We see the points creating a linear pattern, but we do recognize that there's a bigger spread. Now, the last graph has a weak correlation. Notice here, we don't see a linear pattern. Now, we do have a regression line on this scatter plot, but remember, on Google Sheets and Excel, you can insert any data values and you can ask Excel and Google Sheets to give you a regression line. It doesn't mean that it's going to be a good model for the scatter plot. It's just going to give it to you. Okay? So you need to determine, do I actually have a linear relationship? For this one, we would say no. This is really weak, very weak actually. Okay? Now I'm going to add to the description that we have. For the first graph, we describe the correlation as strong. Here, we're also going to take the time to describe the direction of the relationship. So for the first graph, notice as X increases, the Y values decrease. Okay? We also see a line with a negative slope. So here we would say this is a strong negative linear relationship. For graph B, we're also going to add to this description. Notice as X increases, the Y values increase. So here we have a moderate positive linear relationship. Now, again, the last one, it's hard to tell. Notice the line here, the regression line, seems to have a slope really close to 0. So here we're not able to determine if this is a negative, positive. Okay. Actually, we're thinking these two variables might not even follow a linear relationship. Now, I'm going to let you do exercise number 2. I'm going to be adding questions below this video. We're going to read the problem, and then we're going to make sure that you understand what you're being asked to do, okay? So here we have two scatter plots. On the scatter plot we have on the left, we are looking at the relationship between exam 1 and the final exam. On the scatter plot here on the right, we are looking at the relationship between exam 2 and the final exam. Now, you're being asked to look at the graphs. So based on these graphs, which of the two exams has a stronger correlation with the final exam grade? So, in other words, which scatter plot has a stronger correlation? Is it the exam 1 versus the final exam scatter plot? Or is it the exam 2 versus the final exam scatter plot? So you're going to go ahead and answer this question on your own. And you also want to make sure to write an explanation to yourself. I won't ask you to enter your explanation, but I will make sure to provide an explanation below the question. In part B, you're being asked to reflect on why is it the case the one of the exam has a stronger correlation with the final exam. In other words, why is it the case that one of the scatter plots has a stronger linear relationship? There's different reasons why we might be seeing this correlation. Go ahead and think of a few. I will go ahead and mention some of them below this video.